Hello, this is Scott. So today, continuing with engineering applications. Today, we're going to talk about Bayesian reliability optimization for continuous response variables. And so what I have here is I have some tire data. And what this allows us to do is to be able to, this is experimental data, and I'm going to be able to specify four dependent variables, multivariate response, right? So I'm four different variables, and I'm going to have three different input variables that I'm going to use. And I'm going to be able to specify desirability and look for a design space, a result that maximizes the probability that I have my criteria met. And so this hopefully will come even more clear as we go through. But the cool thing is the ability to be able to set a minimum desirability and then an objective function to be targeted. This data actually comes, it's tire data, right? So it's used a lot in academia. It comes from Derringer and Such. And so, again, we want the most desirable tread compound, and we have four Y variables here: the abrasion, the pico abrasion index, the 200% modulus, the elongation at break, and the hardness. And so those are our Y variables, our dependent variables. And then we have the hydrated silica level here. We have the silane coupling level, and then we have the sulfur. So anyway, an example of using a simulated Monte Carlo to determine this. And so what we're going to do is we're going to use Statistica to do this. And so I've got my input data set here. This could be coming from a database. Here it's just a simple spreadsheet, and this is available in the examples within Statistica. But I've got here I'm going to use some R code to be able to do this. Before I get into that, let me just show you. I've got the variables set up here. Again, variables 4 through 7 are going to be the dependent continuous, and then I have the three predictor variables. And so I've got that, and then now we can jump into the node. This is R. If you want to see the actual code itself, I think I've actually got it here. So you can see these packages, R packages that I'm using. But what's really cool is when I use R within Statistica, I get all the version control. I get the ability to create upstream and downstream documents. I get to do a lot more than I would commonly if I just wrote a script and executed an R script here. So couple of things. I'm going to use a random search to design points. I can set this variable. And this is something else about Statistica is that, you know, for someone that doesn't know R and doesn't want to change the code, you can create these nodes and allow them to just change the inputs as they go along. Under the quick tab, I could even set what kind of search that I want. So there are three different options available for the optimization piece. We're going to use the number simulations, numerical search here. But you can see that you would get also select random search or even a grid search available. So again, we'll use numeric. The other thing that we're going to do is we are going to set interactions. So I'm going to set all of the two-way interactions. So if we look back, this was, well, V1 squared, V2 squared, V3 squared, and then the interactions between all of the independent variables. So that was silane, silica, and the other sulfur. So all two-way interactions, the desirability functions I can set here. So the lower bound for the desirability functions, I'm going to set in as, again, 80 for the abrasion, 500 for the modulus, 300 for the elongation, and 55 for the hardness. And then I'm going to do something similar with all of these other bounds too, right? So 200, 2000, 885, and then the target values as well in the experiment, or the I should say the production. And then the S curve, I'm going to set it as 1111, and then the T curve capability. So I get to be able to set those as well. And then graph options, we're going to see, I'm going to set X to be silica, Y to be sulfur. So quite a bit of different options that you can set within the tool. And again, you don't have to be an R programmer or anything. You can set this up for an analyst to run. So let me go ahead and execute, and we'll get some results. And so, well, okay, and well, we're still running. And so I'm maximizing the posterior based upon my criteria. And I'm setting, again, the minimal desirability function. So I've got my output now, and I can look at that. I can kind of scroll through here. I can push these results out to a report. Here's the actual R code and the execution of the R code. Here's the response surface, again, for what I set for sulfur and silica. And I could set multiple of these graphs in the actual probability here. Another one here, just to look at the different views, the actual results here. So in my design, you know, if you look back here, my design space is here. So whatever I'm setting as 0 for silica on the floor to 0, 0, and that's actually going to maximize the probability that I'm going to hit my desirability settings 80% as well. And then here's a 2D heat map for the reliability surface. So anyway, that's a pretty quick tour, but very powerful, the ability to do this, and hopefully that was meaningful. And let me just, I need to get rid of this. Let me just say that this was S77. I hope you're looking at the series. I've done several in the 70 range for engineering applications, but a lot of these out there for you to use. Thanks for your